Hello everyone, so we're going to take a look at how to solve trig equations today. And this is similar to some of the things you've seen previously. It's just going to combine our knowledge of the unit circle with equations that are going to give us conditions to find these angles. So in this first one, we see sine theta equals square root 3 over 2. So this is a very simple equation. And the question now is, at what angle is sine equal to root 3 over 2, right? So that statement, let's go look at our unit circle. So here we are with our unit circle. And so we're looking for where sine, which is our y value, is going to equal root 3 over 2. So I found a couple of them right here. Here's a root 3 over 2 and a root 3 over 2. Remember, this should be the y values for sine. Okay, so these are sines right here. Okay, so what angles was this at? And so we come back down here a little bit and we can see, look, here, 2 pi over 3 and pi over 3 are my angles that are fulfilling this condition. So if we go back to our problem now, so now let's list the angles where we found that sine. So in this case, our sine value was root 3 over 2 at pi over 3 and 2 pi over 3, which were my two solutions. Now you could also have done this in degrees, which would have been 60 and 120 degrees. But in our case right now, we're just going to focus on the radian measurements. Okay, so let's take a look at this second example. Okay, so again, we're here looking at sine, and we're saying it's going to equal negative 1/2. Okay, so go to your unit circle. Remember, sine are the y values. Okay, so find the y values that are negative 1/2 on the circle. So here we are back on our unit circle, and let's find those signs where they are negative 1/2. So I see one right here and another one right here where my y values, my signs, are negative 1/2. So those angles are going to be these pi values listed right here, 7 pi over 6 and 11 pi over 6. So what is the answer to this one? We're going to say, well, this is at 7 pi over 6 and 11 pi over 6. Okay, so we use our unit circle here as a reference for this. Now, the next couple in this group, we see cotangent and secant. These are a little bit tricky, okay? So cotangent is not a value that we are used to looking for on the unit circle, okay? So what we're going to do is we're going to use some of our knowledge of formulas to help us solve this, okay? I'm going to use the fact that we know that tangent theta is equal to 1 over cotangent theta. Okay, and according to this problem, this says that cotangent theta is equal to 0, right? So then I can say tangent theta is equal to 1 over 0. Basically, I just replaced cotangent with that 0 that it's equal to, okay? And this is undefined. So now, again, I'm going back to my circle, and I'm going to find when tangent is undefined. And there should be two spots where this is. So take a second and use your circle to find this. Okay. So the two angles you should find for theta will be pi over 2 and 3 pi over 2. So if you go back to the circle, you can check your work and you can see, hey, yes, that at these two angles, tangent is equal to undefined. Okay, so here we've got secant. Okay, so I need something that can come out of a secant. So look for your formula that has 1 over secant. I hope you found this one. Use cosine theta is equal to 1 over secant theta. Okay, so how about this? Let's say cosine theta equals 1 over this number that's equal to secant theta, 2 root 3 over 3. And this looks kind of ugly, but it's something we can simplify. And we'll use our old friend keep change flip here. 1 times 3 over 2 root 3. And so we get 3 over 2 root 3, but this is ugly, and we need to simplify it before we can find it on our circle. So let's multiply by root 3 over root 3. We get something like this. 3 root 3 over, this makes a normal 3 times 2, which will be 6. And that fraction finally will reduce to this, root 3 over 2. Okay, so I have this statement that I'm going to use to solve. Okay, that was a few steps, but remember, we said that cosine theta will equal root 3 over 2. So now help me. Where is cosine going to be equal to those numbers? Cosine is your x value on the unit circle. Okay, so go back and refer to your formula chart and see if you can find it. Pause the video if you need to. Okay, hopefully, if you looked, you would have found it at pi over 6 and 11 pi over 6. Okay, so those two angles are where cosine is equal to root 3 over 2. Okay, so now hopefully that we've solved those first few problems, we know kind of how to look up the values from the circle. Let's see if we can solve some of these more complicated problems, okay? And in order to solve any of these, we're going to see that we need to get the so-called trig piece by itself, okay? So for example, let's look at number 5. I need to get this sine theta by itself. So I'm going to divide by -2 because I see that it is multiplied by that. So now you'll see that the -2's over here cancel out. My negatives are canceling out over here. So I have something like this. Sine theta equals root 2 over 2. Okay. And again, now, once that trig piece is by itself, we are ready to go look on our unit circle and see if we can find it. Okay. So again, let's go to our unit circle. And on this unit circle, what we'll do is let's look up where sine equals root 2 over 2. So if you have your circle, go ahead and take a second, put your finger on those points. I hope you found these right here. Here's a root 2 over 2, and here's a root 2 over 2 for sine. So what angles will be my answers in this case? It's going to be these right here. Pi over 4 and 3 pi over 4. Okay? So now that we found this, let's back to our problem. And here in our problem, let's record what our answer is. So we found this at pi over 4 and 3 pi over 4. Okay? So those two angles are where sine is equal to root 2 over 2. Okay, let's see if we can do something with number 6. Okay, what do you think we need to do to get our trig piece by itself? Hopefully you came up with that we're going to subtract 1 from here. And so when I subtract 1, I'm left with something along these lines. 0 equals tangent theta. Okay, and so now that it's by itself, I'm again ready to go to my circle. Once again, take a second, see if you can find it yourself. Where is tangent equal to 0? So on our circle, the tangents are these small outside numbers that you can see, and you'll see right here and right here, we've got these tangent values of 0. So there are two angles that seem to work. They are 0 degrees and pi. Okay, so in our problem here, we will say that theta, our angle, can be 0 or pi. Okay, and those are the two radian angles where tangent theta equals 0. Okay, let's look at another one. Now, number 7 looks really, really confusing, but it's not actually altogether that bad. Okay, what we're going to do is, again, try to get this tangent by itself. Okay, let's go ahead and start by getting rid of the 5. That one's kind of the farthest thing from this tangent that I'm trying to get by itself. Now it says 5 minus this, but that's basically a plus 5. So I'm going to subtract this. Okay, that 5 is not being multiplied. Okay, be careful. The only thing being multiplied is this 3/4. So first, let's cancel these out. We got something like this right now. -3/4 tangent theta equals √3/4. Okay, now I want to get rid of this 3/4. So what I'm going to do is I'm going to multiply and I'm going to use negative and I'm going to flip that fraction over. Okay, this negative is only to cancel the other negative out. Okay, let's go ahead and cancel out some stuff. And I have to do the same thing over here, right? So let's multiply by -4/3. These 4's will cancel out quite nicely. And I'm left with a -√3 and a 3. So I've got this. Tangent theta equals -√3/3. So help me out. Where are those angles? What angle gives me √3/3 negative as my tangent? Well, if you look at your unit circle again, there are two of them. There is 5π/6 and 11π/6. Okay, so again, we got two solutions. All right. Try out number 8 on your own, and then I will show you my worked solution for it. So go ahead and pause right now. Hopefully you came to this point where cosine theta is equal to 1/2. Okay, so now that we have that, again, we go to our unit circle. Theta is going to be equal to what? When cosine, my x values on the unit circle, are equal to 1/2. That's going to be π/3 and 5π/3. Okay, and there we go. We've got our solutions. Okay, so let's take a look at these last couple in this group. Okay, so I've got 1 minus tangent squared. Okay, so this one's kind of interesting because of the square here. Okay, that guy makes things a little bit tricky, but it's nothing that we can't handle. Let's first move this 1 over. Okay, let's go ahead and do the same thing we would normally. Let's get this tangent by itself. -1, -1. -1 is equal to negative tangent squared. And these negatives actually cancel each other out, so that's no biggie. And I've got something like this now. Tangent squared theta equals to 1. Now, how would I get rid of a square? What do you normally do in math to get rid of a square? That's right, you take a square root. Now, be very careful. When you take a square root, we get tangent theta. But what's the square root of 1? It's actually not just 1. It is plus or minus 1. Okay? So this is very important. Okay? This is because of the square root. Okay? So now we're actually going to get more solutions because there are more values of tangent that satisfy this statement. Okay? Let's find those angles again on the unit circle. So here we are on the unit circle, and I'm looking for where tangent is either 1 or -1. So let's check it out. Here's my first tangent where it's equal to 1. Here's a -1, another 1, and a -1. Okay, so what angles are these? What are my solutions here? Π/4, 3π/4, 5π/4, and 7π/4, right? So these are the 4 angles that we found that satisfy this equation. So let's list out our solutions here. Π/4, 3π/4, 5π/4, and 7π/4. So these 4 solutions will satisfy this equation. Now, again, we ended up with 4 solutions because this was plus minus, so we ended up with more solutions than we have seen previously. Okay. So last one here, see if you can first get our cosine by itself. This one might be the trickiest one of the bunch. Okay, so hopefully you reached this point where you see that after moving the 1 and the 2 over, I've got this cosine theta is equal to square root 1 over 2 plus minus, okay? And so let's see how this simplifies. So plus or minus square root 1 over square root 2. And this is actually something that we should recognize now. Plus or minus square root of 1 is just 1 over root 2. Now, this seems pretty simplified, but there's one issue still, that root at the bottom, right? So let's fix it up. And when you multiply this, you get root 2 over 2. Still got our plus minus hanging out there, okay? So cosine theta equals plus minus root 2 over 2. I'll give you guys a moment, pause and find your solutions for this. So hopefully you'll have found these: pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4 as your 4 solutions for this one, okay? Now, at the bottom here, guys, we have some extra challenging problems. Feel free to try them out. They just require a little more moving stuff around, but the process is still pretty much entirely the same, okay? So you can solve them all the exact same way. Remember to use your unit circle so that you can look up where the sine, cosine, or tangent has certain values, and you can find those angles pretty easily, okay? Good luck and happy studying with this, guys.